Alright, these next couple graphs are one-to-one initially. And I want you to find the inverse algebraically, and then I also want you to graph the original function as well as the inverse and the line y equals x on your graph, and then find the domain and range. So lots of stuff going on in these problems. So initially, we can go ahead and graph this parent function. It's the graph of x to the third, and that minus 2 on the inside is going to move it right 2, and it's going to move the parent function up 3 as well. So if you remember, this parent function normally looks like this with the 3 dots in the middle, and then the point 2, 8, and then negative 2, negative 8. So if you look at how those points are spaced out from one another, you know, sometimes it helps to kind of sketch that on the graph first. But basically, we're going to take this graph and move it right 2 and up 3. So the new middle of the graph is going to be right 2 and up 3. So kind of imagine that's where the origin, that's at that middle point like the origin was. And then from here we go over 1, up 1, and down 1, back 1. And I don't think we have enough space for the point that's going to be up, because we'd have to go up 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7. If you want to put it on the graph, it'd be right there, right up at 11. And then the other point would be back 2 and down 1, 2, 3, 4, 5, 6, 7, 8. So this would be your graph of h of x, your initial one. Alright, now I'm going to go ahead and find the inverse, and then hopefully the inverse graph will match up, because you really could sit there and just reverse each one of those key points that's on your graph initially, but I like to use that as a way to check my work at the end. I guess we can figure out domain and range right now. This is an easy one. Domain is going to be all real numbers. There's no gaps from left to right. And same thing with your range, but looking up and down. So that should imply that the domain and range of the inverse is also both going to be all real numbers, but let's do it to make sure. Okay, so when you find the inverse, the first thing you want to do is switch x and y. So I'm doing that here, and nothing else changes. Alright, just x's become y's and y's become x's. Alright, and now we're trying to get y by itself. So first we have to get rid of this plus 3 at the end. So go ahead and subtract that over. And then we need to get rid of that cubed before we can get rid of the minus 2 that's on the inside. So to undo cubing something, you're going to take the cube root of each side. So we end up with the cube root of x minus 3 on the left, and on the right we just have y minus 2. And last but not least, we're going to add 2 to both sides. This 2 is going to go after the cube root symbol. So that's your inverse. And if you wanted to, you could, if you don't want to put the y there, you could put the inverse notation. So either way, what we have now is, if we want to graph this, it's the cube root of x, that's our parent function. That minus 3 is going to move it to the right 3, and that plus 2 is going to move it up 2. So if you remember, this is the parent function that looks like this. Here, those same 3 dots in the middle, but we're going to go over 8 and up 2, and back 8 and down 2 for those other points. So this graph looks like that. So keeping that in mind, when we go to graph it on the graph, instead of starting at the origin, we need to move right 3, 1, 2, 3, and up 2. From there, do those other 2 points that were in the middle. And then typically you would count from this center point over 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then up 2. So we're off the graph a little bit, but not too much that you couldn't put it on there. And then the other point would be down 2 and then back 8. Alright. And you can go ahead and connect those. And that's your inverse. I like to do it like that and then go back and double check some key points. This is the point negative 5, 0. So 0, negative 5 should have been on the original, and it was. So here we got 2, 1 here, and 1, 2 there. 3, 2, and 2, 3, 4, 3, 3, 4, and then we have what, 11, 4, and 4, 11. So this is a really nice way for you to check your work. And I'm also going to, oops, not do that. I'm going to draw on the line y equals x, top right to bottom left, and make sure that where they intersect is on that line. And right there. All right, so all three should overlap at the same time. All right, last part of this, domain range of your inverse. If you look at the red graph, your domain is all reals, and so is your range.